Hey there, STEM winners. I want to finish up the back of the notes we started the previous day. So if you want to take out your note sheet from yesterday, that looks like this. All right. We're going to use pretty much a similar approach on the back. The only difference is when we have a GCF, and this actually says 2, we'll say of 2 or more, so you might want to add that in. But when we're using 2 or more monomials, when there's variables and numbers involved, we have to not only break the numbers down, the coefficients, we also have to break the variables down. So I'm just going to start with 76, and we'll do our factor tree. 2 and 38 come to mind, so I'm going to start with that. And then 2 and 19. So it looks like we have a 2, a 2, and a 19 for the prime number. So I'll just circle those here. All right, and then x to the third, I'm just going to write x times x times x. And y to the fourth would be y times y times y times y. There we go. Okay, 32. Here we go. 32 would be, again, you can do any two numbers that multiply to be 32. I'm going to do 8 and 4. And then I'm going to go 4 and 2. And then I'm going to go 2 and 2. So we got a 2, another 2, another 2, and then this 4. You guessed it, 2 more 2s. So we got 2s all over the place. So 32 would be a 2, a 2, another 2, another 2, another 2. And then variables, x squared from the original question up here, x squared would be x times x. And y to the 6th would be y, y, y. That's 4, that's 5, that's 6. Okay, so let's see what matches. We can get a couple 2s here that correspond to the 2s over here. So I'm going to list a 2 and a 2. The 19 doesn't pair up with any of these 2s, so those numbers wouldn't be part of the GCF. So the GCF for the numbers would be 2 times 2, since that's what they both had in common, and that gives you 4. All right, now the x's, if you look at this, we can get an x here and an x here. And then on the other side, there's also 2 x's, or I shouldn't say 2 x's. X times x, so that's going to be x squared. All right, and then with the y's, we got 4 of them here that align with 4 of them here. And so those 4 are what we have in common. So when we're doing GCFs, it's really what do they have in common. So y to the 4th will go there. The GCF is really just the combination or the product of the coefficient and then these variables. So I'm going to use 4, and then we'll have x squared, and then we'll have y to the 4th. And you can put a little dot for multiplication, but realize with variables and numbers, as long as they're written next to each other, it's called juxtaposition. If they're written next to each other, then you can assume that there's multiplication here. All right. Pause the video, try number 2, and then when you're done, I'll go ahead and I'll work through this one with you. So welcome back. I'm going to break 56 apart, and 56 would be 2 and 28, and then 2 and 14, and then 2 and 7. So really that's 2 times 2 times 2 times 7. I'm not going to use the 14 or the 28 because they're not at the end of the factor tree. All right, let's do 140. I'm going to do 10 and 14. And then 10 could break down to 5 and 2. And then 14 could break down to 2 and 7. So we get 2 times 2 times 5 times 7. I always put them in order and go small to big. It just seems easier. Okay, and then for 156, we should be able to do 2 and 78, and then 2 and 39, and then 3 and 13. So our prime numbers would be a 2, a 2, a 3, and a 13. And so we have that's the 2's that combine, or they're all in common. So the numerical part of the GCF would be 4. We got a 5 in the middle group and no 5s anywhere else. And we got some 2's in a couple of them. But like, see, even the 7 here, the 7 can't be used as part of your GCF because it's not in common with all 3 of them. All right, and then when you get to the variables, I'm going to just start with what I see first. So I see y's. We're going to take the lowest power. So there's a 3, and a 2. So this will be y squared. And then the x, we only have one x in the middle term, but no x's on the other one. So you cannot include that as part of the GCF. So 4y squared is the best you can take out of that. All right. Sometimes you're going to get numbers that are considered relatively prime. And when that happens, you're looking at, I'll give you some examples first, like 14 and 15. If you look at the factors that go into those two numbers, they don't have any common factors. So another example might be like 10 and 7. They don't have to both be prime numbers. They just can't have anything in common other than a factor of 1. So I'm going to say two numbers are considered relatively prime if they don't have any common factors other than 1. So like something like these two here, if it asked for the GCF, you would just say, oh, well, since the only thing they have in common is a 1, the greatest common factor would be 1. And basically, anytime the numbers differ by 1, like if 14 and 15 or a 16 and a 17, if they have a difference of 1, then the GCF will be 1. All right, that's all I got for you. Why don't you go ahead for the weekend, finish up on the worksheet, which is the back page of this packet, and that'll be due on Monday. Thanks. Bye.